All right, since it's 2 o'clock, I will get started. Hello, everybody, and welcome to the webinar. My name is Spilza Armadita. I'm a community research and outreach specialist at the Illinois Sustainable Technology Center. Before we start, as a land-grant institution, the University of Illinois at Urbana-Champaign has a responsibility to acknowledge the historical context in which it exists. In order to remind ourselves and our community, we will begin this event by the following statement. We are currently on the lands of the Peoria, Kaskaskia, Pionkasha, Wea, Miami, Muscatine, Odawa, Sauk, Meskwaki, Kickapoo, Tuolumne, Ojibwe, and Chickasaw nations. It is necessary for us to acknowledge these Native nations and for us to work with them as we move forward as an institution. Over the next 150 years, we will be a vibrant community inclusive of all of our differences and with Native peoples at the core of our efforts. This webinar and all the ISTC's webinars are certified green events through the University of Illinois Institute for Sustainable Energy and Environment. To find out more about certified green events through U of I, please visit sustainability.illinois.edu. To find out more about the Illinois Sustainable Technology Center's webinars or to sign up for our events email list, please visit istc.illinois.edu/events. Some housekeeping items. Today's webinar is being recorded and available for the public. PDFs will be distributed after the presentation. During the presentation, everyone will remain muted except for the opportunity for live questions at the end. Questions through the Zoom Q&A feature will be available during the presentation. So if you have any questions during the presentation, please post them there. You will be able to upvote questions you like within Zoom Q&A using the thumbs up button under the question if you have a similar question already posted. I'll be reading the questions to the speaker at the end of the webinar first before we move on to live questions. And at that time, the most popular questions will be asked first, followed by the questions in order they were received. If you have any technical difficulties, please send me a private chat message. Today's speaker is Dr. Nicole Deziel. Dr. Deziel is an associate professor of epidemiology in environmental health sciences and co-director of the Yale Center for Perinatal, Pediatric, and Environmental Epidemiology at Yale University. She obtained a master's of industrial hygiene and doctorate in environmental health from the Johns Hopkins Bloomberg School of Public Health. Her research is focused on applying statistical models by monitoring techniques and environmental measurements to provide comprehensive and quantitative assessments of exposures to traditional and emerging environmental contaminants in population-based studies. Dr. Deziel's contributions have been directed at two main areas: exposure and human health impacts of unconventional oil and gas development, or hydraulic fracturing, and residential exposure to chemicals in common consumer products, and cancer risk. Without further ado, this is Dr. Deziel with Emerging Environmental Exposures and Cancer, the case for hydraulic fracturing and hormone disruptors.
Great. Thank you so much for the opportunity to speak with you today. I'm going to be talking, as was said, about environmental exposures and cancer risk with a focus on pediatric cancers today. And I'll talk about two of my main areas of research, fracking and endocrine disrupting chemicals. So pediatric cancers, as well as early onset cancers, those in young adults, have been steadily increasing over the past several decades. And pediatric cancer in particular has been ticking up at about 0.8% per year, which may not sound like a lot, but year after year, this does start to add up to substantially more childhood cancer cases, with about 15,000 children in the US diagnosed each year with some sort of cancer. And although survival rates have been improving, so mortality has declined over this period, cancer does remain the leading disease-related cause of death among children. And there have been many large-scale genetic sequencing studies to try to look for hereditary factors, genetic causes for these cancers. And those studies have really only attributed about 10% of childhood cancers to some sort of heritable genetic variant. So that leaves many cases to some sort of environmental or lifestyle factor. And we have known about environmental and occupational carcinogens for over 250 years. You may have heard of Percival Pott, who was a British surgeon who identified that young men and boys who were employed as chimney sweeps had higher rates of scrotal cancer, and he attributed that to the soot. And that was indeed proven. Later research pointed to the polycyclic aromatic hydrocarbons, or PAHs, which are widespread pollutants today, as the etiologic agent. But this work really paved the way for informing exposure reduction strategies like improved hygiene and personal protective equipment, and also paved the way for legislation protecting these young workers. So just to show the importance of kind of at first identifying these associations so that risk mitigation steps can be introduced. Also, there have been many studies that have tried to estimate what proportion of these childhood cancers could be due to environmental pollutants specifically. And these studies have different estimates, but recent studies have concluded about 15% of childhood cancers could be specifically attributable to like environmental chemicals. However, this may be largely underestimated, in part because we have over 80,000 chemicals in commercial use, registered for commercial use, and only a small percentage have actually been adequately tested for carcinogenicity. So there's just a lot of gaps in what we know here. Oops. Okay, so with that introduction, I'd like to turn to my first case example with the endocrine disrupting chemicals, which I will introduce. These include many emerging and legacy chemicals in relation to pediatric thyroid cancer risk in particular. So first, I want to just set the stage for adult thyroid cancer. This is one of the fastest growing malignancies. The incidence rates have tripled in a recent 30-year period. Can see from these graphs that by the scale on the graphs that the incidence rates in women are much higher, 3 times higher than that of men. And the rates have been increasing over time. Now, at least part of this is due to improvements and changes to how we diagnose thyroid cancer. So there have been many advancements in imaging techniques and screening procedures, which likely have identified thyroid nodules that would have remained indolent and wouldn't have progressed to a serious disease. So we call this overdiagnosis. And you can see some awareness about this has led to sort of more of a flattening out or decline in more recent years. However, many studies have looked at this and have concluded that this changes to diagnostic scrutiny can only cannot explain this whole trend, and that environmental and lifestyle factors could explain up to 50% of this increasing trend. And then also of great concern, pediatric thyroid cancer has been increasing over a similar time period. And similarly, rates are higher in females compared to males. And children are much less likely to be targeted for aggressive screening and imaging. And we've also seen increases in the larger tumors, which, the small ones are the ones that may not progress. So all of this suggests that this is not solely attributable to diagnostic changes. And pediatric thyroid cancer is of particular concern. Any cancer poses risks, disruptions to life milestones like education, family formation, work, occupation, employment, and children do tend to present at more advanced stages, have larger tumor sizes, and also are at risk for then secondary cancers, for example, from radioactive iodine therapy. So in my group and others have hypothesized, could this increasing incidence in thyroid cancer be due to increasing exposures to thyroid hormone disrupting chemicals in the environment and in our homes and our food systems? So I'll be talking about those types of chemicals. Many different products contain thyroid hormone disrupting chemicals. And I just wanted to say a word about endocrine disruptors. I wasn't sure if this audience was familiar with these, but the endocrine system is this highly choreographed physiological system that is responsible for regulating many aspects of the body, and communicates through different messengers. And endocrine disruptors are chemicals that either mimic or compete with are naturally occurring thyroid hormones, kind of perturbing this whole system, this well-choreographed system, so that it can lead to kind of overproduction of different hormones or suppression of different hormones. And one example of this is the polybrominated diphenyl ether flame retardants, or PBDEs. And in this schematic here, I'm showing the chemical structure of penta PBDE, one of the common formulations, and the metabolized form of it here. And here on the bottom, we see the naturally occurring thyroid hormone in her body. And, you can just see, even if you're not a chemist or haven't taken chemistry in a long time, it's, the structural similarity is very clear. Instead of bromines, we have iodine, different halogen, but it's readily apparent how this chemical could compete with, or the body could mistake this chemical for the thyroxine, the thyroid hormone, which could trigger a whole cascade of events, including, overstimulation of thyroid hormone, thyroid hyperplasia, potentially leading to cancer. And this just, again, shows this very well choreographed feedback loops that the hypothalamus pituitary thyroid axis works by, and how these hormones can disrupt this. So if there really is an association between these chemicals and thyroid cancer, the next thing we might ask is, well, have the levels of these chemicals increased over a similar time period? And here's some plots just showing some time trends of these different thyroid hormone disrupting chemicals, like the PBDE flame retardants in archived blood bank samples. And remember that cancer, like thyroid cancer, has a latency period of decades, so it's very sensitive. There's this increasing trend that kind of precedes the increasing trend in incidence, kind of parallels this. Also, PFAS, the per and polychlorinated alkyl substances, the forever chemicals, are very widely studied emerging set of contaminants right now. Many of those have increased over a similar time frame, although it really is kind of a mixed picture, because some of the well-studied ones like PFOA and PFOS have now decreased due to more awareness or phase outs of these chemicals, but other replacement PFAS have continued to increase. So again, it's not a clear trend, but there are some increases of certain thyroid hormone disrupting chemicals. And just a couple other examples again for PFAS and the PBDE flame retardants, for example, in California, where they had very strict fire safety laws and some of the highest exposures in the US. So in adults, some of these chemicals have been studied and compared to thyroid cancer risk. And results are overall suggestive, but somewhat mixed. So numerous studies have documented some association between exposures to these thyroid hormone disrupting chemicals and adult thyroid cancer risk, but results haven't been totally consistent across studies or across chemicals. A lot depends on the study design. So I think more work needs to be done here. But something that did emerge from the studies of adults was that adults that were exposed earlier in life seem to be at greater risk for developing thyroid cancer. So that provided some biological basis for trying to study this more carefully in children. So I'll just highlight a little bit of some of the adult studies that I led the analyses with the PI of this parent study, Yao Chung, the Connecticut Thyroid Cancer Case Control Study. In this study, we looked specifically at women because they were at higher risk, and collected blood samples of people who had cancer, women who had cancer, and women who didn't have thyroid cancer, and measured their blood samples for a whole suite of different thyroid hormone disrupting chemicals. And overall, we didn't see an association, but when we stratified by when the women in this study were born, we found that women born after 1960 during the peak production period of polychlorinated biphenyls or PCBs, we did see this kind of consistent increased risk. And this trend was also observed in this other study led by the National Cancer Institute. They found something quite similar. So when it comes to children's cancers, thyroid cancer, we really know very little. The only established environmental risk factor is radiation, which comes from accidental exposures from children exposed from Chernobyl or other major radiation releases. But for all these other chemicals like PFAS and flame retardants, we really have no information. So I wanted to talk first about one study that's just underway that I don't have results for, but I think this has the potential to really shed some light on this question. We're looking at in utero exposure to legacy and emerging thyroid disrupting chemicals and thyroid cancer in children. And we have this large case control study of 500 children who went on who developed cancer and 500 controls. And we have obtained neonatal dried blood spots. So when all infants are born, there's a heel prick collected, blood is analyzed to screen for congenital anomalies. And in California, they archive these blood samples, which can be used for future research. And my colleague, Dr. Crystal Pollitt, she can use just a small piece of these blood samples to measure an array of different chemicals. And then we can look to see where the children who had higher levels in their bodies at birth, were they more likely to be the ones who went on to develop cancer. So we can look back and compare the children with cancer and children without cancer and see if there were any differences in exposure. So this is just getting underway. But I will tell you about a new study that was just published in the last week or so in Environmental Health Perspectives. In this similar population, we know where all the children were born. We have geocoded residential information, and we use that to look at other thyroid disrupting agents like air pollution or fine particulate matter, PM 2.5, and outdoor artificial light at night. Now, PM 2.5 is a known human carcinogen. labeled so by the International Agency for Research on Cancer. Air pollution and particulate matter is this complex mix of carcinogenic and endocrine disrupting chemicals, a whole variety of different constituents. And it has been suspected, there's been some evidence that its exposure to air pollution is related to thyroid hormone disruption. And similarly, being exposed to light at night, artificial light at night, has also been linked to multiple cancers in adults, as well as one study of childhood leukemia. And this is plausible due to the relationship between thyroid hormones and our circadian disruption, and how that could, again, perturb thyroid hormone system, leading to cell proliferation, kind of out of control cell death, DNA repair, or metabolic alterations. So we, in this study, had over 700 children who were diagnosed with thyroid cancer in California. And for each of those, we matched them with 50 children who did not have cancer, who were born in the same year. And we had all their addresses at birth that we mapped and then linked to these various high-performing models using satellite remote sensing to assign exposure to light at night. And then this air pollution model developed at Harvard to look at air pollution, PM2.5 ambient concentrations at birth. And again, see where the children who were more exposed, were they more likely, did they have a greater likelihood of developing cancer compared to children who weren't exposed. So in this epidemiologic study, we did find a significant association between outdoor artificial light at night and pediatric thyroid cancer risk. And I think this is a multidisciplinary audience. I'll just kind of say what an odds ratio of 1 would indicate no association, and odds ratios above 1 indicate like a 1.23 odds. That means 25%, 23%, or 1.23 times greater odds of developing thyroid cancer in this third group with the highest exposure. And this was statistically significant. Also, we looked at light at night continuously, also saw statistically significant association overall with thyroid cancer risk. And then we also looked at different age groups. Pediatric thyroid cancer is highest among the kind of teenagers, and we saw a much more pronounced association among this older age group, not among the younger 0 to 14 years of age. We also wanted to look by race and ethnicity. This population in California is over 60% reporting as Hispanic, and in this population, the Hispanic communities lived in areas with higher air pollution, may also experience other cumulative burdens. And for this, we didn't see that much of a difference, but actually the odds were a bit higher in the non-Hispanic white population, but similar trends overall. And we adjusted for many different confounders in these analyses. We also saw a significant increase between air pollution exposure and pediatric thyroid cancer in this study, again, with the highest exposed group having 1.27 times greater odds, or 27% greater odds of developing thyroid cancer. We didn't see that much of a difference between the age groups. And in this case, actually, the associations were more pronounced among the Hispanic children. So this study provided some of the first evidence that I'm aware of, suggesting relationships between early life exposure to outdoor artificial light at night and outdoor particulate matter and pediatric thyroid cancer risk. This is only the first study, so it's important to replicate this or see if these associations hold up in other populations. And the suggestive but inconsistent findings between exposure to thyroid disrupting chemicals and cancer risk in adults, I think suggests that more research in children who had early life exposure is needed. And I want to acknowledge all the funders and collaborators for this particular set of work. And I know we'll have time for questions at the end, so I think I'll move now into my second case, which is about unconventional oil and gas development, or fracking. But also would welcome questions. I know you can put questions in the chat for the first case study. So unconventional oil and gas development, or UOGD, or fracking, has increased substantially over the last 15 years, with this graph showing the production of shale across the country in different areas, like in the Appalachian Basin, of where I do my research, like the Marcellus Shale. Also, the Permian Basin is an area where we're seeing a lot of growth. And this widespread expansion of this industry has led to over 160,000 active fracked wells in the US, and about 4 million people living within a mile of a fracking well, and about 9 million people living within having their drinking water source within 1 mile of a fracking well. And just to explain UOGD, or unconventional oil and gas development, anyone's not familiar, the more conventional way of extracting oil and gas is by drilling a well vertically to some sort of reservoir that's very accessible, like low, like a porous rock formation, and it can just be pumped up directly. In contrast, unconventional oil and gas development involves drilling a well vertically 1 mile or 2 below ground, and then turning the well bore directly into this very low porous, low permeable rock, like shale, kind of like concrete. Then millions of liters of water, chemicals, and sand are pumped down the wellbore under extremely high pressure and expelled into the rock, creating fracks or fissures. And then once the pressure is released, oil and gas that is trapped within that rock can flow up the well. But accompanying the oil and gas is also the fluids that went down in the first place, and also ancient briny water that's also stored within the rock, and that can contain naturally occurring radioactive materials, arsenic, lead, various elements that are kind of in that rock material. So then all these millions of liters of wastewater have to be managed at the surface and kind of disposed of. And, there are, in this picture, schematic, you can see that when the well does pass through the drinking water table, the aquifers, there are additional layers of cement and steel casing to try to protect the water supplies. But, there have been demonstrated leaks, spills at the surface, and things like that. So this complex multi-phase operation can release many environmental hazards, whether it's air pollution and diesel exhaust from the construction vehicles, truck traffic, bringing materials to and from the well pad, greenhouse gases such as fugitive methane leaks, radioactive materials, as I mentioned, this leaks and spills, and also you may have heard about the seismic, like mini earthquakes, typically more from the disposal of that wastewater that's generated. And the drilling can be, in some cases, very close to homes. I mean, sometimes people, invite the drilling on their property and can earn some, royalties and things like that. But, different states have different rules for how close you can drill to a home or school. So in my research group, we've been looking at unconventional oil and gas development from many different angles, water contamination, environmental justice, but today I'm going to focus more on children's health and children's cancer. So I've been working on this topic for almost 10 years. And when we first started, there were just a lot of question marks about this new industry. So one of the first things we did was try to get a better handle on what were the types of chemicals that were being emitted either to the air or the water from this process. So my former doctoral student, Elise Elliott, first did this analysis, just looking at any chemicals that had ever been used or emitted or detected in the wastewater or used in the fracturing fluids, and whether or not we had information on their carcinogenicity. And so we had this list of over 1,000 different chemicals, not suggesting that there's 1,000 chemicals used at every well, but this was a list of any chemical that had ever been reportedly used or generated from this process. And as I kind of indicated in the very beginning, we only had data on, I think, 20% of the chemicals. Most of them had not been evaluated for carcinogenicity. But of all these over 1,000 chemicals emitted, there are about 55 that were known or suspected carcinogens and 20 linked to leukemia specifically. And some of the examples were benzene, 1,3-butadiene, radon, arsenic, diesel exhaust. So there have been a few studies, as far as I'm aware of, 4. Well, actually, there was just a brand new study. Should have updated this. There was just a brand new study from Lisa McKenzie. She did an updated analysis. So I think as far as I'm aware, there's 5 studies looking at fracking and childhood cancer, just pretty limited. And I'm going to focus on our study here that was published a couple of years ago. So in our study, we decided to focus on acute lymphoblastic leukemia. Leukemia is a cancer of the white blood cells. This is the most common cancer subtype in children, and it arises from immature B and T lymphoid immune cells, thought to be as a result of kind of multiple insults, genetic damages. And this could be due to some sort of genetic factor, like a heritable genetic factor, or environmental exposures could create this damage to these cells. So this is a schematic of our study population. Again, this was a large registry-based study where we obtained all the cancer records for the state of Pennsylvania here and linked them with birth records and geocoded all their addresses, similar to the previous study methods I described. And I'll just skip to the bottom line that we had 429 cases of children with leukemia and 5-to-1 matched controls. And again, went back and tried to reconstruct what their exposure was at birth. And exposure in this case was how close did they live to an oil and gas well. And we used a few different metrics to try to capture exposure. Unlike the air pollution study where we had specific data on like light or PM 2.5, here we're dealing with this complex industrial operation, and we don't really have data on what chemical. We don't even know what the etiologic agent would be, and we don't have monitoring data for all those different chemicals that are used in this industrial operation. So instead, we look at how close people lived to oil and gas wells. And we can look at kind of the number of wells and give more weight to those that are closer. And then we also collaborated with some hydrogeologists to weight or really just count wells that were hydrologically up gradient of the residence. And why we did that was because a well could be very close, but if the water is flowing away, the water flow is kind of away from the oil and gas well, a home's drinking water well would unlikely be contaminated by some sort of spill. So we created this additional metric to try to look specifically at the drinking water pathway. We also created different time windows for our exposure metrics because the etiologically relevant time window for childhood leukemia is not known. So we looked at the perinatal period, which is thought to be an important window of susceptibility. We also looked at the entire prenatal period all the way up until a year before diagnosis. In the end, even though we tried to do these more advanced exposure metrics, we because leukemia is so rare, we didn't have a lot of exposed cases, so we ultimately just had to classify people as exposed or unexposed. We weren't able to take full advantage of these models that we had developed. So here's some plots again of the odds ratios. Here, the exposure groups are 2 kilometers, so having an oil and gas well within 2 kilometers of the birth residence, 5 kilometers or 10 kilometers for our 2 different windows of exposure. And you can see that we saw the statistically significant association with twice the odds of developing childhood leukemia if children had an oil and gas well within 2 kilometers of their home. And you can see how as we increase this buffer size and we consider wells that are farther away, the association gets attenuated, you know, suggesting closer was really what was more important. And the effect estimates were a little more pronounced when we just focused in on that perinatal exposure window, but our confidence intervals were a little less precise here. And this was led by another former PhD student, Cassandra Clark. Here's the results when we used that water-specific metric. Basically, they were consistent, but a little bit attenuated. We had a little less precision with our confidence intervals here. So just to highlight some of the challenges when trying to study pediatric cancers and the environment, you know, the outcome is still quite rare, fortunately, but that does mean statistically is kind of challenging because since we have very few children who actually do develop cancer, you know, having sufficient exposed cases kind of poses the statistical challenge. With fracking in particular, it's this complex source with numerous hazards, and there isn't monitoring data available to, you know, estimate exposure in a more specific or precise way. However, we use these studies that are registry-based studies. This means we're able to include all children who have cancer in an entire state, but when we use these types of studies, we're not interviewing or interacting with the population. So we are kind of limited to what we can adjust for in terms of kind of confounders and things like that. So I think for this fracking study in particular, it would be helpful to do a larger study, which Dr. McKenzie has just published on and actually found kind of similar consistent results. Again, we want to really consider not just how close you are to an oil and gas well, but which way is the wind blowing, which way is the water flowing, to try to improve our models, and also consider some other cancers, perhaps. And I think enough time has elapsed, enough latency period has elapsed that we could also look at some adult cancers in particular. And if we were able to do a study where we enrolled people, we could try to adjust for a broader range of confounding variables. So I just will highlight that some of this research, particularly with oil and gas, was of great interest to the public. Fracking came up in presidential debates. It's always a hot topic, an emerging topic. Some of our research, as well as that of others, has been used to update those allowable setback distances, how close you can build to a home. So some of our research is informing some updates to these types of setbacks. And with that, I'd like to acknowledge all the funders and collaborators who worked on these particular studies as well. And with that, I will be happy to open it up for questions.
Wonderful. Thank you, Dr. Deziel, for the insightful presentation. We'll start the Q&A. There's a couple questions on here, but if you do have the desire to ask a question live, just raise your hand and then I'll give you the mic so you can ask directly to Dr. Deziel. The first question is there any suggestion of indoor artificial light having a similar effect?
Yeah, great question. This actually points to somewhat of a limitation of our study. We only had data on outdoor light at night, but yes, absolutely, indoor light at night would be expected to have similar effects and probably even stronger effects. So outdoor light at night is going to be influenced by window treatments and whether there's other like appliances and things on inside the home. So we have, wearable devices that can detect light and sleep. So I think looking at that would be another next step for this research to kind of get a more accurate picture of what children are exposed to. So right now it's just kind of capturing kind of broad contrast in outdoor light at night. And I could maybe add a little bit too that this is not just for children, for adults, things that disrupt our sleep, even like shift work, people who work constantly changing their work time, sleeping during the day, going to work at night. There is evidence that those occupations have greater risk of cancer, in part due to these kind of disruptions to circadian rhythms. And other factors as well. Cancer is always very multifactorial.
The next question that is already upvoted, have you explored agricultural chemicals as possible causes?
Yeah, so thanks for that question. In my research, I have looked at pesticide exposures in relation to childhood leukemia and other cancers. And many pesticides, I'll point out, are endocrine disrupting chemicals. And yep, there are a lot of studies out there, like the agricultural health study looked at farm families and cancer risks. And yeah, farmers are generally have lower risks of many diseases, in part due to many healthier lifestyles, physical activity, low smoking rates, but people who work in agriculture do have higher rates of certain cancers that may be attributable to pesticides. I guess I will say in our fracking study, we adjusted for pesticides to try to isolate oil and gas. But yeah, so there and many others have looked at pesticides in relation to childhood cancer. There is pretty consistent evidence actually linking pesticide exposure and childhood leukemia.
All right, great, thank you. The next question is very interesting talk. Is it known if the chemicals released from fracking that make their way into drinking water can be carried from the woman's body into her breast milk? Of course, if this can happen, this would extend the exposure of an infant after birth.
So first, let me kind of take this in two parts. One, I could talk a little bit about kind of the evidence for drinking water contamination. While there definitely have been instances of communities' water being impaired, there isn't evidence of systematic kind of widespread contamination from fracking. We led a study where we went to hundreds of homes in Ohio, Pennsylvania, and West Virginia. And we found some elevated levels of some pollutants, but generally the people's drinking water, the levels of contaminants in drinking water was quite low, far below kind of health-based standards. So while there is a possibility of drinking water impairment, it does seem to be a little more localized or episodic, rather than just if you live near fracking well pad, there isn't evidence that just living near there contaminates the water. But regarding the breast milk, there have been some studies in Canada where there were some pregnant women living close to oil and gas wells. Not sure if they looked at breast milk. I guess so. I'm not sure I can directly, I don't think there's been studies really that have looked at this, but I will say that chemicals that do accumulate in breast milk are typically very lipophilic, very fat soluble. And yeah, so we do know that that can be an issue and a pathway for exposure, but no one has connected all those dots together.
All right,
I hope
thank
that
you.
answered the question.
All right, next question is, do you think that there is any hope of the US moving to a system like the EU's REACH, registration, evaluation, authorization, and restriction of chemicals, where manufacturers have to prove that the chemical is safe, instead of the Toxic Substance Control Act, which places the burden of proof for a product's negative effects on the government? Does your research aim to contribute to this discussion?
This is a great issue. So as I mentioned a couple of times, we have thousands of chemicals authorized for commercial use, yet little data on their health status. And this question is absolutely right. In the US, the way our regulatory framework is set up, researchers like myself have to show that a chemical is harmful, or the burden of proof is to show that a chemical causes harm before having to prove its safety at the outset. And this is different than the regulatory framework in Europe or other countries where they take a more precautionary approach. So I guess, I'm not sure about the policy, the likelihood of policy changes, but I guess I would say, really this really demands a policy level solution. This is not something individuals can sort of shop their way out of, to quote one of my colleagues, with these, for example, the PFAS and PBDEs in our home products it's microplastics, whatever. It's very difficult to, if not impossible, to avoid some of these chemicals based on personal consumer practices. So they really do beg for a regulatory solution. Similarly with oil and gas, the solutions need to be more at the policy level. There are some things individuals can do to improve the quality of their home, their indoor air and water, but yeah, I would certainly like to see more policies. And I would like to thank my research as contributing to this by, again, I tried to do a lot of outreach, including giving some testimony where relevant to try to improve some of our policies to be more public health protective.
All right, thank you. The last question that I have here, please put in more questions or raise your hand if you have any. What would cause bone cancer is the question. I believe this person is asking about the risk factors associated with bone
Yeah,
cancer.
that's a great question. I don't know as much about bone cancers, but there are, at least from an environmental perspective, there are some established risk factors, including radiation. Like people may be aware of the radium dial girls, women who painted watches that glowed in the dark, and they from radium, and they would lick the paintbrushes to make a very fine pointed tip, and then developed these rare cancers, bone cancers of the jaw, these different sarcomas. And then some people in Pennsylvania think there could be a, a suspected cancer cluster for Ewing sarcoma, a rare childhood cancer. But that's still like under investigation. It's very hard to investigate that, but that's kind of the extent of what I can say about that specific cancer type.
Thank you. Go ahead, Beth, with your question.
Sure, thanks. What role do microplastics or nanoplastics play in the disease and contaminants factor?
So microplastics is another emerging issue. It's not something I'm specifically working on, but what I can say is kind of wherever we're looking, wherever scientists are looking, they're finding microplastics. It's in well water, it's in bottled water, it's in tea bags, it's in placentas, it's in testicles. It's in our body. So we know there's widespread exposure. What does that mean in terms of health risks? If any, we're kind of a long way from figuring that out. And there are many challenges to studying this, like, do we count up the number of little plastic particles? Is it the constituents of the plastic? Plastics can absorb other chemicals. Is it the size of the little plastics? Is it like their shape? Is it the type? We know plastics have like 1 to 5 or 7. There's all different types of polymers. So I think this is an area of very active research. I just don't think we have a lot of answers yet.
Yeah, thanks. The second question, what do you see on the horizon as like that's going to be a big emerging contaminant in the future that's going to impact disease and cancer?
Oh, that's a really good question. Yeah, I think I need to think about this. Is a very good question. I probably should know. I've been kind of focused on these, the PFAS and fracking, but yeah, there's always as these things kind of we gain more awareness about certain classes of chemicals, a new one kind of emerges. I mean, there's the neonicotinoid pesticides that have been shown to have these ecological effects, like on the bees, have not yet been well studied in humans. And I think the microplastics is another one. Again, where it's kind of on people's radar, but we still don't have the research to support it. Yeah, I mean, and then there's a lot of other. I guess another area that there seems to be a lot of attention on is just like ultra processed foods, which again is kind of a complex mix of, is it preservatives, pesticides? So I think that's another one where it's thought to have there may be a link to cancer there with ultra processed foods, but I'm not sure what about the processed foods it would be.
Okay, yeah, thanks.
Thank you.
Thank you. I saw a raised hand, but I'm not sure if that was a slip up. Is there any other question from the audience? You're welcome to just raise your hand. All right. If there's no more question, I would like to thank Dr. Deziel for the presentation and answering a plethora of questions today. We will be sending out the recording as well as the PDF. So if you have any questions about that, you should be getting that shortly. Other than that, this will be our last webinar for the semester, so be on the lookout for new webinars in the fall. It's been a pleasure, and thank you everybody for tuning in until the end. And thank you, Dr. Deziel. We appreciate
Thank you so much, and thank you for all the great questions. Appreciate it.
Thank you. Bye, everyone. All right. Thank you, Nicole.
Okay, thank you. Bye.
Thanks. Bye.